Hi, Assalamualaikum and a very good morning. So today we're going to do chapter 11, which is amine, and we're going to focus on the subtopic of 11.5, which is the chemical properties of amine. In this video, we're going to look into the reaction in order to distinguish different classes of amine by using the Hinsberg test as well as the nitrous acid test. Also, we're going to look into the identification test of aniline using bromine water. Next, we're going to see the formation of dye by the coupling reaction of the diazonium salt, or known as the benzene diazonium chloride, with phenol. So without any further ado, let us start. So for the Hinsberg test is basically used in order to differentiate between the different classes of amine, which is the primary, secondary, and tertiary amine. The reagent used for the Hinsberg test is going to be the benzene sulfonyl chloride, and it's going to have the structure of the benzene ring attached with the SO2Cl group. So for the reaction of amine with the Hinsberg reagent, which is the benzene sulfonyl chloride, it's going to involve two steps. The first step, the amine going to react with the benzene sulfonyl chloride with the presence of excess KOH or NaOH, either one of the basic here. Next, the mixture going to be acidified by using the hydrochloric acid. And as what you can see from the reaction of the two steps here, each class of amine going to give a different set of visible result after each of these two steps. Okay, now we're going to look into the observation between the primary, secondary, and tertiary amines using the Hinsberg reagent. Okay, so for primary amine, let's say if we have the primary amines here, where the amine here is attached with one alkyl group, so it is known as the primary amine. So the primary amine here can also be an aromatic amine, for example, aniline, or it can be any aliphatic amine. Okay, let's say 1, 2, 3, which is a propanamine. Okay, as long as it is primary, the Hinsberg it can undergo the Hinsberg test. Okay, so for the result for the Hinsberg test for the primary amine, so we're going to react our primary amine with the benzene sulfonyl chloride, and from the reaction of benzene sulfonyl chloride, we're going to remove the HCl from the reaction mixture, and this will causes the N and S bond to be connected. Okay, and this happens in the presence of excess KOH. So when N and S bond are connected, the hydrogen here going to be replaced by the potassium metal. Okay, and as a result, what we're going to get is the Rn, the K going to enter here, and the HCl going to be removed as the byproduct, and NS bond going to be forming. Okay, and this is a soluble salt because of the presence of the metal group here. And because it is soluble in salt, because it is soluble in solvent, we can say that it is producing a clear solution. Okay, so this is for step number 1. For step number 2, the reaction mixture going to be added with HCl in order to acidify the mixture. So what's going to happen here is that the K plus going to react with the Cl here in order to produce KCl, and the hydrogen going to attach with the NH bond here. So it's going to become NHR. Okay, so you're going to form NR and NH, and this is going to forming a white precipitate, mendakan putih. Okay, and the byproduct here is not that important to us. What's really important is the amine product here. Okay, so for step number 1, you're going to produce a clear solution. This is the observation. And for step number 2, it's going to produce a white precipitate. Okay, and now we're going to move on to the secondary amine. So the same, secondary amine can be a primary amine. Secondary amine can be an aromatic amine or the aliphatic secondary amine. Okay, so the secondary amine can react with the benzene sulfonyl chloride, and this gonna remove the H and Cl in order to produce the HCl here. Okay, and this happens in the presence of excess KOH. However, the K here cannot replace the alkyl group. Okay, instead, for the primary amine, the K, which is the metal, can replace the hydrogen, but in here, the potassium cannot replace the methyl group. So what's going to happen here is that the HCl going to be removed and NS bond going to be formed and the R group here is still maintained. Okay, and since it does not have any metal group here, it's going to be a white precipitate, mendakan putih. Okay, so this is for step number 1. And then for step number 2, we're going to acidify the mixture using HCl. And what's going to happen here is that there is no metal group here, so it cannot react with the chlorine atom. So when it is acidified, we does not see any changes. So we can say that there is no observable changes and the white precipitate gonna maintain. Okay, masih sama, white dengan white. Okay, for tertiary amine, okay, so the tertiary amine here can be an aromatic or aliphatic, doesn't matter. Okay, so as long as it is a tertiary. So for the tertiary amines, when it reacts with the benzene sulfonyl chloride, what's going to happen here is that in the presence of KOH, there are going to be no reaction or no observable changes because we are talking about the identification test. Okay, because there is no hydrogen that can be taken out from the chlorine. Okay, in secondary and primary, the hydrogen is attached with nitrogen. However, in this case, the hydrogen is attached with carbon. So we cannot take up the HCl from here. We need to take up the hydrogen from the nitrogen in order to make the bond. Okay, so in this case, the reaction will not occur. And what we're going to see is just a clear solution. So we can say that there's no observable changes and clear solution going to be formed. Okay, and if we continue to add acid in order to acidify the mixture, there will be still no observable changes and the clear solution going to still maintain. For the summary, I have written it here. So for step number 1, for the primary amine, when it is added with benzene sulfonyl chloride with KOH or NaOH, first we're going to produce a clear solution. But in step number 2, when we add HCl or white precipitate going to be formed, so CW. However, for the secondary amine, we're going to get white precipitate, and the white precipitate gonna remains when we add the HCl. For tertiary amine, doesn't matter aliphatic or aromatic, what we're gonna get is a clear solution. After addition of HCl, we're still gonna get a clear solution. So we're gonna get CW, WW, and CC here. Okay, so maybe that will help you to memorize better. Okay, so CW, WW, CC. Okay, now we're gonna look into the next test, which is the reaction of amine with the nitrous acid. So the nitrous acid, which is referred to HNO2, can be used in order to distinguish between the primary aliphatic amine and the primary aromatic amine. Also, it can also be used to distinguish between primary, secondary, and tertiary aliphatic amine. Okay, and the nitrous acid here is always prepared in situ, secara terus. Okay, how can we prepare it secara terus? So we can prepare it directly by using the cold sodium nitrite, which is NaNO2, with an aqueous solution of the cold dilute hydrochloric acid. Okay, at the low temperature, which is 0 to 5 degrees Celsius, and that is why the cold here is being emphasized. Okay, so sodium nitrite can react with the hydrochloric acid at low temperature in order to produce nitrous acid, which is HNO2, and the byproduct here going to be NaCl salt. Okay, and now we're going to see the reaction of the aliphatic amine with the nitrous acid. So for the primary aliphatic amine, it's going to react with the nitrous acid at low temperature, which is 0 to 5 degrees Celsius, in order to form the diazonium salt. The diazonium salt is basically unstable, and hence it will be decomposed further in order to produce alkyl halides, alcohol, alkene, and nitrogen gas. So they're going to be forming 4 different products. Okay, and in order to understand this better, let us look into the general equation here. So let's say if we have an primary aliphatic amine here, and then we're going to react that with the sodium nitrite with HCl. So this reaction here gonna form nitrous acid. Okay, and this happens at low temperature because it needs to be prepared in situ, right? So what's gonna happen here is that they're gonna form a diazonium salt. So diazonium salt gonna be looking something like this, which is R N triple bond N plus with X minus here. Okay, and this is called as the diazonium salt, which is unstable. Okay, so when it is unstable, it's gonna be decomposed further in order to produce nitrogen gas, because here you can remove it in order to form nitrogen gas, and as a result you can also produce R plus and X minus, which is a cation as well as anion. And as a result of this reaction, you're going to produce an alcohol, alkyl halides, as well as an alkene. Okay, so for your level, you can just directly say that primary amine, primary aliphatic amine, react with the nitrous acid will give these four different products here. Okay, and as for the observation, you can say that the gas bubble evolve, okay, because they're going to be a bubbling in the beaker, right, at low temperature, and this indicate the nitrogen gas is being released. Okay, so now let us look into the same example using a primary aliphatic amine. So let's say if you have an ethanamine here, which is 2 carbon, okay, and here refers to the R group here. Okay, so when it react with the sodium nitrite with HCl at low temperature, you're going to produce four products, right? So you're going to produce an alcohol, which is an ethanol, where R group here is still maintained. Okay, you just add OH, and then you're going to produce a haloalkane, which is the same one, and then you just add Cl because the Cl is coming from the hydrochloric acid. And then you're going to produce an alkene, which is CH2 going to be one of the hydrogen going to be taken by the X minus ion, which is the chloride ion, and this is going to form a double bond, which is an alkene, and then the nitrogen gas going to be produced as the because of the unstable diazonium ion. Okay, and this for the observation, you can see that the gas bubble going to be evolved, indicating nitrogen gas is released. Okay, and as mentioned, you can just directly use this equation here and give four different products. Okay, now we're going to do the reaction of nitrous acid, but focus on the secondary aliphatic amine. So the secondary aliphatic amine react with the nitrous acid at low temperature to form nitrosamines, and it appears as a yellow oil. So for example, if you have a secondary aliphatic amine here, which having two alkyl group, and it's going to react with the nitrous acid, which is prepared in situ at low temperature, what they're going to produce is a nitrosamine here. Okay, so as you know that this combination here going to produce HNO2, right? So the HNO2 can also be written as HONO. Okay, one hydrogen, one nitrogen, two oxygen. Okay, this hydrogen here can be removed, and then N gonna form bond with NO in order to produce nitrosamine. Okay, so maybe you can visualize it better when you write it in terms of this way. Okay, and this nitrosamine here is going to be appear as a yellow oil. Okay, let us look into the specific example here, which is the secondary aliphatic amine as well. And then we're going to react that with the nitrous acid, where I asked you to use the HONO style. So the hydrogen and the OH from the nitrous acid going to be removed as a byproduct of water, and the nitrogen going to form bonding with the NO here. So it's going to produce a nitrosamine, and a yellow oil going to be produced. So for the observation, you can see that the yellow oil is formed for the secondary aliphatic amine. Okay, and this is how you distinguish secondary and primary amine just now. Now we're going to look into the tertiary aliphatic amine. So when the tertiary aliphatic amine added to the nitrous acid at low temperature, it dissolved to form a trimethyl ammonium ion, and hence forming a colorless solution. So let's say if you have a tertiary aliphatic amine here, react with the nitrous acid at low temperature, what you're going to produce is a trimethyl ammonium ion. Okay, and this is going to produce a colorless solution. And hence, for the observation, you can just say that the colorless solution is formed. Okay, so we are done with the aliphatic. Now we're going to look into the aromatic, but we only talk for the primary aromatic amine. So the primary aromatic amine basically refers to benzene ring attached with amino group, okay, or known as aniline. Okay, so the aniline gonna react with the nitrous acid at low temperature in order to form arene diazonium salt, which is a very stable salt. Okay, so let's say if you have a primary aniline here, a primary aromatic amine, which is the aniline, it's gonna react with the sodium nitrite with HCl at low temperature, which is the nitrous acid, and what they're gonna produce is a arene diazonium salt or arene diazonium chloride salt because they have chloride. So this structure here is very stable, not like a primary aliphatic amine, because the primary aliphatic amine gonna decompose, right, to give four product. For aromatic, it's gonna be very stable. Okay, unless okay, so it's gonna be stable at low temperature. But when we apply heat, what gonna happen is that the N2 gonna be released. Okay, so as a product, you're gonna form a phenol, and the N2 here gonna be released as nitrogen gas. And this happens when it is above 5 degrees Celsius. Okay, so you can say that for the observation, there will be no gas bubble evolve or release unless heated. Okay, so tiada bubble kecuali dipanaskan, which is greater than 5 degrees Celsius. Okay, and for the summary, you can say that the primary aliphatic amine, the gas bubble going to be evolved. Tetapi untuk primary aromatic amine, there will be no gas bubble evolve unless dipanaskan. Okay, untuk secondary amine, secondary aliphatic amine, yellow oil, which is nitrosamine. Untuk tertiary aliphatic amine, colorless solution ataupun clear solution is formed. Okay, so here is the summary. Okay, and now arene diazonium salt, as what you see here, as mentioned, it is a very stable salt. This compound here can be used in order to produce dye. Okay, benzene and triple bond and chloride. So it can be used in order to produce dye. So we're going to look into the coupling reaction using the arene diazonium salt. Okay, so the primary aromatic amine, as I showed just now, which is the diazonium ion, is very stable. So it can undergo coupling reaction with the aromatic compound with a strong electron donating group, which is, for example, a benzene ring attached with OH or the benzene ring attached with NR2, which is below here. Okay, at the para position to yield azo compound. Okay, azo compound here refers to dye. Okay, so what's going to happen is that in the coupling reaction, the nitrogen is being retained in order to make a bridge between the two benzene ring. And the azo compound that we are talking about is a intensely colored use as dye. Okay, sebagai warna. Dan dia adalah berwarna sangat terang, intense color. Okay, and to explain more about point number 2 here, it basically means that the reaction of the arene diazonium salt gonna maintain the N triple bond N here. Okay, and this Cl here gonna take the hydrogen from this part with the Cl minus here in order to form hydrochloric acid. Okay, dan dia ni berlaku dekat para position, which is 1, 2, 3, 4. Okay, where para here refers to 1, 4. Okay, kalau ortho 1, 2, meta is 1, 3. So it happens at carbon number 4. So Cl and H gonna be removed, and the arene diazonium salt, and here gonna attach with the carbon number 4 here in order to produce this structure. Okay. Okay, 1, 2, 3, 4. So 1, 2, 3, and 4. Okay. The same goes to this situation here. Okay. So similar thing happen. 1, 2, 3, 4. H here gonna be taken out with the chloride ion, and the N bond gonna be maintained, and here is used to make a bond in between carbon number 4 of the Nr2 group here. Okay, and this gonna produce our dye. Okay, so the first one here gonna produce an orange azo compound, which is an orange color dye, pewarna warna orange, and below here gonna be a yellow dye, pewarna warna kuning. Okay, and the color comes from the difference in the electron donating group. Kalau OH, dia bagi warna orange. If NCH3, NCH2, CH3 here gonna give a yellow color. Okay, and we can see a lot more example, but for your matriculation is only involve these two process here for the coupling reaction. Okay. Now, we're going to look into the last test, which is the identification test for aniline. So for the identification test of aniline, we're going to react that with the bromine water. And aniline, which is in the benzene ring, is the octopara director. What is meant by this? So let's say if you have an aniline, and then you're going to react that with the bromine aqueous in the presence of water, what's going to happen is that the aniline or the amino group here gonna causes the bromine to attach at carbon number 2, carbon number 4, and carbon number 6. Okay, so here is carbon number 1, 2, 3, 4, 5, 6. Okay, and octopara director means that it will allow the bromine to attach at the ortho position. So ortho adalah 1, 2 kan? Meta is 1, 3, and para is 1, 4. Okay, this one is on the left hand side. On the right hand side, we also have ortho, meta, and para. Okay, so what's going to happen here is that the bromine going to attach at carbon number 2, at carbon number 4, and carbon number 6 because it is ortho, para, director. Dia mendirect bromine atom to attach at carbon number 2, 4, and 6. So what's going to happen here is that it's going to form a 2,4,6 tribromoaniline, which shows a white precipitate. So you can say that for the observation of aniline, when we react with bromine water, the bromine water gonna get decolorized. Okay, the reddish brown color of bromine decolorized. Okay, that's for observation number 1. And for observation number 2, we can say that the white precipitate gonna be formed. Okay, so I think that's all for today's video. See you again some other time. Bye!